So here we have the 2019 higher paper. This is paper 1, question 16. This question here focuses on circles and equations of circles within a system. So a question asks us if we've got a point P, which is given by coordinates there, and we've got a circle with a centre C given by that equation. I've got two things I need to do. Firstly is I need to show distance between the point P and C is given by that, and then hence or otherwise find the range of values of K such that P lies outside the circle. So a couple of things to address here. Now the first thing I want to remember is this here, the equation of the circle and how it lines up. Now the equation of a circle, remember, looks as x plus a squared plus y plus b squared equals r squared. And it matches up with each part here. Now in this, a and b, that represents the centre. So in this case, that would represent the point C for this question here. So if I were to start on part A, what I'd be able to do is look at, interpret this information and say that the point C, the centre of the circle, is given by 1, negative 2. So that there is the centre of my circle. What I then want to do is use the distance formula to show the distance between this point and this point here. Now remember your distance formula is given as the square root of x2 minus x1 squared plus y2 minus y1 squared. Where x2, x1, y2, y1, they come from the coordinates. So let's take it and we'll start substituting the points in. So let's make this point here x2, y2, this point here x1, y1. I know that it would then be given by the square root of 4 minus 1 squared plus k minus minus 2, so that would then give me k plus 2 squared. Now that I've got that, I could start to multiply out the brackets. My hope would be to go from this up to this. So let's see if that happens. So I then end up with the square root, so 4 minus 1 is 3, so 3 squared is 9, so the square root of 9, plus then multiply out this bracket here, I get k squared plus 4k plus 4. Gather those terms together and simplify. I get the square root of k squared plus 4k plus 13. Lo and behold, exactly what I want up here. Now, part B asks me to find the range of values of k such that the point P lies on the circle. Now remember, if we've got a circle and we've got a set point, there's three things it can do. So there's my centre of my circle. I can either have the point P somewhere inside here, I can have it sitting on the circle, or I can have it outside the circle. Now remember, there's three conditions that could be used for each of these. First condition is that if the distance between the centre and the point is less than the radius, then the point lies within the circle. If the distance between the centre and the point is equal to the radius, then my point lies on the circle itself. And if the distance between my centre and my point is greater than the value of the radius, the point lies out with the circle and in the space beyond. Now that there's the condition that we want to satisfy in order that the point P lies outside the circle. So what that then means is this distance formula has to give me the fact that the square root of k squared plus 4k plus 13 has to be greater than the radius r. Now if I look at the original circle equation up here, I know that r squared is 25, so my radius squared is 25. However, this here also has an implication that if I get rid of this square root, I've got k squared plus 4k plus 13 has to be greater than r squared. Now I know r squared is 25, so I could just substitute that in straight away. I know that k squared plus 4k plus 13 has to be greater than 25. And if I start to look to solve this quadratic inequality, shift it all here so that it's greater than 0. So k squared plus 4k is not going to change. If we then got 13 take away 25, so we've got minus 12 has to be greater than 0. And to solve it, what I have to do is start to look at factorising it. If I factorise it, I then get k plus 6, k minus 2 is greater than 0. So from that I get values that k equals negative 6 and 2. From solving this here and looking at the brackets, k is negative 6 and 2. Now what I have to do is look at this and figure out how I can interpret it and what the values mean. So if we were to use a table of values, let's imagine that I've got my value of negative 6 here, I've got my value of 2, and what I'm going to do is look at the k's. So if I take k being below negative 6, so let's say for example k is negative 7, and I were to substitute that into here. So k squared plus 4k plus 13 greater than r squared. So let's actually focus on this format here. So I then get negative 7 squared, so that's 49, plus 4 times negative 7. So 4 negative 7s are negative 28, so that would be 49, take away 28, take away 12, so that's 49, take away 40, which is 9. So it's always going to be positive up to we hit negative 6. When we hit negative 6, it's going to be equal to 0, so we're not interested in the value at negative 6. We then look at a value between negative 6 and 2, somewhere in this range. So let's imagine 0. So I'd get 0 squared plus 4 times 0 minus 12. Well, that's negative. So that's going to be below 0. If I then look at any value above 2, let's say 3, I'll have 3 squared, which is 9, plus 4 3's, which is 12, minus 12. So that's going to be 9. So that's then going to be positive, which is greater than 0. So what that then means is if I take any value here and here, I'll always get a value which is greater than 0 for this. However, if I pick a value here, I'll get negative, so the inequality does not hold. So what I'm able to say then is by looking at interpreting this, therefore, if the value of k is less than negative 6, or if k is greater than 2, that implies that the point P lies outside the circle. So there we go. That's us got our solution and our interpretation of that solution. You need to make sure you know this formula up here. You need to make sure you know and understand how the circle formula relates to the information you're given and how we can use it and interpret it. You also have to understand this fact here. You know, how can we look at the relationship between points and circles? How do you know whether they're inside, on it, or outside the circle? What the distance formula is and how that can help me when I'm doing the work here. Now for this question here, part A was worth 2. So you got one part for finding the centre, and then you got the second part for substituting in here and then leading to that. Remember, you can't just write down the distance formula and then say equals this. You have to show what you're doing with the information, so the point C and the point P, by substituting it in, then expand the brackets and get to that formula. You also wouldn't get the mark if you went straight from this step to this step in one jump. You'd have to show multiplying out the brackets and then simplifying to get it. That would get you your second mark there. Now you'd also get the first mark for the point here if you just wrote the distance formula down and actually were able to imply it from that. You know, it could be implied at this stage and you'd be able to read off the centre of the circle. Part B is worth 4 marks. Firstly, you have to interpret the information and get to here, so knowing that it's greater than the radius, so what condition it has to meet. Secondly, we then have to substitute in the r squared and get to this stage here. Thirdly, getting the values for k, which this would give us in terms of our solutions to a quadratic, if we were to equal 0, so think of it in terms of that, and then interpret it. I used the table of values. There's a variety of ways you could do it to get the two sets of solutions here. You have to have them like that. You could also have used a sketch at this point to have a look at it. So for example, you could have used a sketch of a quadratic that cut down and went through like this. You got the value of 2 here, the value of negative 6. You could have found the value of your turning point and then shown that it's negative for all the values here, it's positive for all the values here, and that's where it exists. So there was another way you could have approached that second part. Bottom line is you have to get these two sets of values and your interpretation has to be accurate. Table of values, or look at the physical graph itself and see what you can get. This question here, again, circles comes up every year, some characteristic of it. This happened to be what they interpreted and tested that session. Make sure you know all the skills associated with it and you know how to do it, apply them and interpret them accurately and effectively and communicate your answer clearly.